22.
Okay, can everybody see that?
Yes.
Great, okay. So, Module 3, Introduction to Transformers. So, it talks about a transformer consists of 3 basic components. That's a primary coil, a secondary coil, and a core. Let's take a look at the primary coil. So the primary coil consists of electrical wire wrapped around a core. The source voltage applied to the core. So what they're saying here on the primary side, it's a coil wrapped around, and we're gonna apply some energy across that core. Okay, going into the secondary side. The secondary side of the coil also has a core wrapped around it. The voltage from the primary, it kind of induces a voltage on the secondary, okay? Let's look at the core. The core is typically there's a ferromagnetic material that is capable of conducting magnetic fields of iron. A magnetic field. Iron is a common material. That's one of the most common materials. So it induces what they call mutual inductance. When you have the windings of the primary and the secondary close in proximity, and the primary is wrapped around a core, electricity flow. Then what it does is create electricity and voltage in the secondary as well. They got a picture of it trying to show you that. I tried to show the first group and going back to Amitral, but it locked up the machine, so it didn't work as well. Peter, you want to add to this?
Sure. So, like Dave says, what the core provides is a strong magnetic field. If you ever took 2 magnets and put them close together without physically touching, you could feel the 2 kind of pulling to one another. They want to basically attach to each other. And that's kind of how a transformer works. It has 2 separate windings. One's called the primary and the other one's called the secondary. The primary and the secondary are not physically, electrically connected. What happens is when the current flows through the primary coil, it sets up this gigantic magnetic field. And the energy from the primary actually gets moved into the secondary. So even though they're not physically connected, you actually could generate voltage across the secondary because of this magnetic field. It's the same way like your cell phones. When you obviously your cell phones are not connected to one another, but you get text messages and phone calls. And that's because this planet uses magnetic fields to allow a signal from one cell phone to go into another. And that's kind of how the transformer works. The purpose of the core is just simply to provide a stronger magnetic field so that we can make sure the energy from the primary gets into the secondary, okay? And so that's kind of how it works. Remember though, guys, that the secondary and primary are not physically electrically connected to. You can wrap the primary and secondary on top of one another, but they're not electrically connected because each winding is laminated and protected.
Cool.
Okay, let's go to the next page. Well, Peter described the function of the core. We did the primary and the secondary. Okay, so here we talking about turn ratio. Did everybody, I don't know, did everybody submit their answers to me by his email? If I didn't get it from you, I'm not gonna say it's too late, but I like to get it because we about to go over some of these here now, okay? So let's look what they talk about here. Turn ratio. And this is how you calculate whether you're looking for the turn ratio of the primary versus the secondary, or you're trying to find the voltage drop in the primary or the secondary. So turn ratio equals the number of turns of the primary over the number of turns for the secondary. Let's look at the first example, what they talk about. So on the primary side, which is the left-hand side of the transformer, the secondary side is the right-hand side. So on the right-hand side, the number of turns they got in the core, in the windings is 100 turns. And the secondary, they got 50 turns, okay? One of the things that you can find out of this real quick is this going to be a step up or step down transformer? So a lot of
Step
times,
down.
a lot of time you can look at the number of turns. It'll give you indication if it's going to be a step up or step down, or you can look at the voltage and which way it's going, and you can determine if it's going to be a step up or step down. So this is what they call a step down transformer, because we got 100 turns on the primary, and on the secondary, we got 50 turns. So they're trying to find out what the turn ratio is. So you put 100, which is the primary on top, divided by 50, that gives you 2/1. The number 2 is the primary. The number 1 is the secondary. So you call that 2-to-1. So you got to make sure you put the colon in there. It's 2-to-1. 2-to-1. If you mess around and you just put 2 and you forgot to put to 1, like the colon and the 1, you got like half the problem. I mean, you got half of it right because you got to put 2-to-1 down. Let's see, let's go on. This is a bad one because what it did was it cut down all the information that was on the other side. And we'll do some more of these in our work problem. So we'll do these in our work problem. So I'm gonna skip this page. Let's look at this page. So if we want to find it, we already found out how we can find the number of turn to turn ratio. How about if we want to find out what's the power going into the secondary of the transformer? So here's the formula for that. The voltage of the secondary equals the voltage of the primary divided by the number of turns, okay? The number of turns for the primary to the secondary core. So let's look at what he's saying here. So the voltage of the primary is 240 volts. Okay, and the voltage of the second, oh, they give you the voltage of the secondary. Oh, they already give it to you, 120. Why is they looking for it? So anyways, so if we had the number of turns, I guess they just wrote the answer in there. If we knew the number of turns, right, and we got 50 over 100, and the primary, once again, the primary always goes on top, the secondary go on the bottom. So if the primary is 100 and the secondary is 50, so we got 100 over 50, we can break that down to 10 over 5, right? And 5 go into 10 2 times, right? So this would be a step-down transformer, 2-to-1. 2-to-1. Seeing that this is a step-down transformer, if they gave us the voltage for the primary was 240 volts, then we would have to take 2 and divide it into 240, which would give us 120. I got another setup for this in the lab, which I can show you as we go along with it. I can highlight some stuff, okay?
Yeah, one thing I like to add is just remember, guys, when the turns ratio goes down, like in this example, 100 to 50, then you're always going to divide the primary voltage. In other words, you started with 100, but you went down 50. So 100 divided by 50 it's a ratio of 2. So you just divide the voltage by 2. So 240 divided by 2 is 120. So when the turns ratio goes down, you're just going to divide. If the turn ratio goes up, then you're going to multiply the voltage. So you can have a step down or step up. And so in this case, 100 to 50, and that's 100 divided by 50 is the number 2. And the reason why the voltage steps down is because you have less wire on the secondary. Less wire means a weaker magnetic field. There's a less electricity because you have less wire. Okay, so when you have less turns, it means you have less wire that can hold the voltage, and that's why the voltage goes down by a factor of 2. Okay, if that was reversed, guys, it was 50 on the primary, 100 on the second, then what would happen to the voltage? It would double that. It would be 480 on the secondary. So that's all you have to remember. If the turns ratio is going down, you divide. If the turns ratio is going up, you're going to multiply. So,
Okay,
Okay.
that's
come
my
on,
2
Peter.
cents.
Thank you.
Okay, let's go to the next page. Let's look at a control transformer operation. 4 basic components of electrical control circuit. Okay, there's 4 basic components, and the 4 basic components are a power source. Okay, the power source, the power supplies are the device that provides the source of power needed to create an electrical current. So here they're showing you what they call a DC battery. Okay. On the 85 MT5, we're going to be using AC voltage. Okay. But for here, they're just showing you a regular battery. Number 2, an input device. An input device gives the operator controls of when or how current flows in the circuit. So one of the examples of an input device would be a regular switch. On an operating station, I'll give you a few seconds to think about it. On our operating station, what do we have on our operating station? We have a push button. Normally, we got a push button 1. That's an input device. Push button 2 is an input device. How about push button 3? That's an input device. We normally use that for an emergency stop button. We also have a selector switch, okay? These are what they call considered input devices, okay? If you got an input device, you need an output device. Output devices are the component in the circuit that uses the electricity. So an output device would be something that you can read, something that'll give you information, that might give you sound, like a horn, output. A horn will come on when it's got a problem, when something is not running right, or our indicating station. We have a red light, a yellow light, and a green light. It's notifying us that something is happening. So we got sound, we got light. These can be output devices. And last but not least, is the conductor is nothing but wire. So we need some type of way of transferring this electricity from the power to the switch input device or to the output device through conductor or wires, okay? So the conductor are the materials through which the current flows, okay? Okay. This is our objective. This is our objective. Describe the function of electrical schematic drawing. We want to work on learning how to read a schematic instead of pictorial or picture. It's always good to know how to look at a picture and identify with it. But as technicians, we need to understand the schematic. So let's look at this first pictorial diagram. In this first pictorial diagram, right, you have a battery source, you have a switch, then you have a light. They all connected together through a wire or the conductor, okay? We're looking at a picture. What if we had 100 devices that we had to put in this circuit, right? We probably have 100 sheets of paper, right? Or versus this. Let's look at a schematics diagram where they show you what a battery, the symbol of a battery look like. The input switch or the output of a light, okay? I think Egyptians was I think the Egyptians was amazing, right? Because they went out, they was able to take a hammer and a chisel, or however they did this stuff, right? And they chiseled things into the bricks. They chiseled what water looked like flowing down a stream, or an animal, or a cow, and you know what I'm saying? And they did all this with just they didn't have a pencil like we did, or paper. You know, I mean, can you imagine us using a hammer and a chisel and to communicate on a scale like that? So we use schematics to break that stuff down for us. Okay. You want to add to that, Peter, or anything?
No, I'm good.
Okay.
You explained it really well.
Once again, there go the symbol. It shows a battery, the switch, and the lamp, all in series with one another. What kind of battery it is? Okay, this is a DC battery, straight line. It's not AC, but it's DC. And the current flows when the switch is closed. So we got to understand, not only do we got to understand the picture and the schematic, we need to understand what it's doing. In order for the light to come on, we need to close the switch because the switch is open. Any questions?
Nope.
Okay, going forward. Okay, once again, that's a battery, that's a switch, and the lamp. Okay, this didn't come out too clear because some of the stuff got erased. So we just gonna look at the power source. Our power source that we really gonna be dealing with is AC. But this is a picture of a DC power supply. And down at the bottom is AC with the squiggly line going up around. That's our AC, okay? Okay, I need y'all to pay close attention to this. And Amazon made a bad mistake when they put this together like this. Ah. What page? Anybody know what page I was on?
$29.
It was this one. This one. Page
Yeah,
11.
it's it.
Yep,
It's
that's
in
it.
Amatrol as 29, I think.
Oh, okay, so everybody can see this?
Yes, I
There,
can.
there's not an error with this. The way they have it designed, it's probably designed like this out in the field, but this is not our setup. Y'all see these two fuses? Y'all see the two fuses? One is next to the push button station and the other one is towards the motor. Y'all see them fuses? Them fuses are supposed to be on the primary side of the transformer, not the secondary side. It's not saying that this won't work, but we're not using this design setup. Them fuses should be on the other side of the transformer. So I like to say it's an error, but then again, I can't say it because they probably run this like this in the field. But for our purpose, we don't do it like this, okay? And we'll discuss this a little bit more in one of the next segments, okay? So let's talk about this. The primary side is the side that's going up. Let's split this transformer in half from the core. And everything going up from H1 to H2 is the motor portion. That's the power section. That's where our high voltage is at. 208 from L1 to L2, L2 to L3, and L1 to L3. That's the high voltage. That's the power section. Everything split from the transformer core going down from X1 to X2 is the control portion. Okay? That's the control portion. So it's separated. What they also are saying here, when the power that is supplied to the control circuit is different than the power supplied to the motor, it is called, oh, so we got to get this terminology down. Let's go back up. When the power from the control circuit is taken directly from one phase, that means either L1 in neutral or L2 in neutral and L3 in neutral, we can use that to give us 120 volts to go across the circuit for us, but we don't want to do that because that's that's not the way that this transformer theories work, okay? So when they talk about when the power is supplied to the control circuit is different than, watch this, when the power supply that is supplied from the control circuit is different than the power supplied to the motor, it is called a separate control and requires a transformer to supply a different voltage. So what they're saying here is we tapping off of two of the phases to go into the primary. We could easily have just said phase one for L1 and L3 or L2 and L3. They just tapped off of L1 and L2. That's going to be a separate circuit than the bottom half, which is the control portion of it. And I got a little bit more information on that when we go on, but I just wanted to explain that to you. And they work independently amongst each other. I doubt very seriously, like it's a high percentage that if something in the power circuit fails, it won't affect the circuit in the bottom half or vice versa, okay?
Just to add one thing about that schematic is, and just to reiterate, Dave, this is one of the advantages of three-phase power, guys, is because you could tap off and be able to get 120. They're using a transformer though in this case, so there's no neutral. Remember what Dave had mentioned way back is that when you have you have L1, L2, and L3, there's no neutral shown. So when you tap off the two hot wires, remember we use a DMM, you get the 208. But what's great about transformer here is that this transformer is a step down. We're taking the 208 and then stepping it down to 120 on the secondary. And so you can now use a three-phase motor, but then you can use the 120 for a single-phase motor. So the secondary is basically the 120. So that's the whole point of a transformer is that different loads need different voltages, and with the transformer you could get the 120. In terms of the fuses, Dave is absolutely correct. You need fuses on the primary. If the secondary is typically greater than 50, you should have at least one fuse on the secondary. So he's right. Our trainers, they don't use fuses on the secondary, but like David said, in the field you usually will see a fuse also on the secondary because the voltage on the secondary is still quite high. It's 120. If the secondary was only like 10 volts, then you wouldn't have to worry about fuses. But because you're still dealing with high voltages and currents, you still want a fuse. But he's absolutely right. Remember, we have those two fuses we checked last week. That's for the primary side. So I hope that makes sense.
Thanks, Peter.
No problem, Dave.
Once again, guys, a step down voltage. Many industry motors operate on a voltage that are higher than the voltage rating for the control devices. So your control device is going to probably have 120, while your motor is going to be we doing low voltage 208. Once again, this here is showing you a schematics of the control transformer circuit. It's a dotted line going across the center of it to let you know everything below the dotted line is the control circuit. Everything above the line is our power circuit. Remember when we hooked up? Remember when I told you, I said, I like to always go up and wire my high voltage and come back and do my control circuit, because there's a button that I can push. There's a button that I can push manually to make sure my motor turns. So if my motor turns, you probably got like 75 or 80% of that circuit built.
Okay.
Go ahead. Was you saying something, Peter?
No, it wasn't me. It was someone else.
Okay. Oh, somebody had a question?
No, I just said okay.
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 So watch this. I think I discussed this earlier. the control circuit isolation. A transformer isolates the primary from the secondary. If there's a short or if there's a short circuit, the transformer is bad. It isolates everything from the primary side to the secondary side. That's what they talk about the isolation. Typical transformer configuration. So what I'm gonna do here, guys, because these pages, these upcoming pages are so messed up, there's different type of configurations that we gonna be doing. There's only one configuration that we gonna be doing. And I just wanna go to that configuration because these are a bunch of other configurations that you can set a transformer up with. See, these pages didn't come out clean like I wanted to, but nevertheless, we are going to be working with this configuration. Everything is not here, but I did do it on another link, and we're going to see it later on. So right now, what they said, we dealing with 208. We just concerned about input 208 on the primary. We don't care about 277 volts. We don't care about 380 volts on the primary side. All we concerned about is setting, this will be pin 2 and pin 3 on the primary side. We're gonna put 208 volts going in, and coming out of that, we're gonna get 120 volts coming out, okay? There's multiple taps on the transformer that we have out there at Northland, but we only concerned about the 208 tap. Okay, there's two ways to test a transformer, okay? So this is one of the things you guys gonna have to do. I think this is your activity 2. Skill 1 is to wire up. And skill 1 and skill 2 is to test and get your measurements, okay? This here is not a good example of, we're gonna bypass this because we're gonna do this together. Once again, guys, yeah, let me show this one. Please understand your meters. If anybody got a meter that they picked up from the store, great. It don't matter what kind of meter you got, just learn how to use the meters, okay? So here what they're trying to show you is they're looking to see if it's an opening in the coil, the opening in the secondary. So if this was an opening, what you would see on the meter is infinity, okay? It would be infinity, okay? If this was a working transformer on the secondary, you probably see around 6 volts. Your lab will tell you what type of, not volts, but ohms, resistance. Now, we try to test for resistance. We're not testing for continuity. We're not listening for sound, okay? We're not looking for voltage, so you don't need to use your volt. You don't need to have volt set to this. All you're trying to do is read the resistance of the secondary. You do the same thing for the resistance of the primary. You're not looking for a sound, you're trying to read the resistance of it. Right here, they talk about an opening. So if it was an opening, you'll be reading infinity, okay? Here they talk about a short between the coils. So if you're on the primary side, right, and the leads don't matter, guys. If you got black and red lead, when you're doing continuity or resistance, it don't matter where you have the red lead here or the red lead there, or the black lead here or the black lead there. It don't matter. Even with the AC power, it don't matter. Only thing when you measure a DC power, you want to make sure your leads are in the correct position. They'll give you the voltage, but it'll give you a minus reading. So here they're trying to test the short between the coils. So if you get a reading between the primary side and on the secondary side, and if you get a reading of a short circuit, this transformer is bad. You got to replace it. Okay? Any question on that? Once again, they're looking for a short. They're going across a short instead of an opening here. If I measure across the secondary side of the transformer, and if this thing zero out, if it shows me like maybe 0.1, 0.2, or 0.3, that's a short. Anything other than maybe 6 ohms, or whatever the book will tell you, then it's considered a short. Once again, they measure from the core to one side of the transformer, whether it be the secondary or the primary. If it's a short circuit and it zeroes out, the transformer is bad. Okay, we done with that. Great. Any questions? Any questions on that?
Nope.
Okay, let's
How'd you
look
get to outer space?
Okay, let's look at. I wanna go. You know what? I should have kept on sharing because all I had to do was hit my tab. I screwed that up. So I want to go back. I still want to go back to here. I screwed that up. I should have stayed where I was at. Okay, y'all see, I'm back on transformers, right?
Yep.
Okay, so I need to do this, module 3. Everybody got their module 3?
Nope.
Who don't have module 3?
Teddy, I dropped the ball.
Okay, do me a favor.
Okay.
Draw this out. Take a quick, just draw a transformer, just draw this out right quick if you can.
Okay.
Take about 5 minutes. Let me know when you finish.
Okay.
You finished? Okay, once again, guys,
I
look.
said I'll let you know.
Oh, okay, I thought you was done.
That was like 35 seconds, man. What do I look like? Superman?
Oh, okay.
I wish I could drop that fast.
Meanwhile, while he's doing that, y'all guys, look at where the fuses are at. Look at the fuses. Where's the fuse at? The fuse is in the primary side, not the secondary side.
Yeah.
Right? If we think about this, watch this. Watch how good you guys got already. If y'all think about the schematic, you probably can determine what the heck is going on without looking at a picture of it. Think about L1 and L2. Where's it coming from? And they're going into the fuse. Now you're coming out of the fuse and look where it's going to. What side of the transformer?
Coil.
Our transformer is not set up like this in reality, but it's still the same principle. That's still the primary side. Even though it's 90 degrees flip, it's still the primary side of the transformer.
Okay.
Cool? Everybody else, I'm assuming everybody else got module 3, right? Hey, Peter,
Yeah.
and remind me before we turn off, because I got to make sure, remind me to go shoot over to Northland, see if I can get module 4 and take them out to North Campus, because I got a lot on my head, a lot of things. in my
Okay.
mind. Okay.
All right. Yep.
I'll try to take care of that today.
Okay. Almost done.
Okay. I truly appreciate you guys coming in today. So Savannah never made it in, huh?
Nope.
Apparently not.
If the video come out right, I'll send it to him.
All right, I'm good. Thank you.
Okay, great, great. Everybody, let's take a quick look at this. So we know what L1 and L2 is going to give us, right? How many votes? How many votes going across L1 and L2 will give us?
120.
120. Deborah. Here,
Oh,
come and
240.
What? No, 208. That's our 208.
Oh, that's a 208. Okay.
Yeah. So everything, now if these fuses are good, a fuse just act like a piece of wire, right? So what are we gonna see on the other side of the fuse?
Wire.
Now, how many voltage, voltage,
Oh,
sorry. How many voltage on the other side of the fuse?
208.
208. What's gonna be on pin 2 and 3? On the primary side?
120.
No, primary side.
208.
208. The other thing I want you guys to remember, you see this 2 on the primary side with 3? Don't misconstrue that 2 with the 2 on the secondary side. 2 different type of 2s.
Okay.
I've seen people wire that by mistake and thought it was the 2 on the primary. And we had to come and check and tell them, no, you could have blew some fuses there. So don't get them misconstrued. So that's going to give us 208. We need 208 volts on the primary side in order for this transformer to give us 120 volts out on pin 2 and 5. 2 and 5. Don't worry about pin 3 and 4 because they're internally connected in the transformer. There are metal jumpers inside the transformer that's already jumping. You don't have to worry about that, okay?
Mm-hmm.
So let's look at this here. So we got pin 2 is going to the left side of what? Pin 2 is going to where? Let's follow pin 2
Switch.
down. To the switch. To select the switch.
Yep.
Hey, Peter, is they doing ladder logic?
That's next.
Oh, okay. So
Yep.
this is part of ladder logic. Okay. So we're on the left-hand side of the switch, right? Now, is this switch open or closed?
Open.
It's open. What to close this switch?
Well, it's a selector switch,
Yeah,
so it's a manual thing.
yeah. So the L, you see the L? The L represent left side. So if you turn that switch to the left, these two contacts will join together because the switch makes contact with this here selector switch coming down. Then you got a contact there. If it was the right-hand side, they didn't put right in there because they're not using it. So if you did the right-hand side, that means you would have to turn the selector switch to the right side. And then would have made contact, okay? Now see that we talk about the left-hand side? We turn it to the left. What condition is the light in right now?
It's off.
It's off. Until we do what?
Turn the switch.
Turn the switch where?
To the left.
To the left. Now
Right.
we got power. Now let's look at the right-hand side of the light indicator. Follow that light indicator wire and where is it going to? Follow the wire.
Up to L1.
No. The
Oh,
yellow light.
5.
Number 5.
Okay,
Yep.
watch this. Watch this, guys. That 5 is showing you the symbol of a ground, right?
Oh, yeah.
Watch this. Anytime we come off of, you want to write this down.
Mhm.
Anytime we come off of pin 5 or the secondary of the transformer, I want that colored wire to be green. Green.
Right.
I don't want red. I don't want white. I don't want blue. I don't want no iridescent. I want it to be, I don't even want it to be black. I want it to be green,
Green. Got it.
okay? Coming out of 5 is green. So if the wire coming out of 5 is green, let's go back to the light on the right-hand side. Follow that wire. What color wire should that be?
Black, white.
Somebody else take a guess.
I'm thinking black.
Okay, now watch.
That was my
If this,
first guess.
if this wire here is coming out of the light, going into 5, if 5 is green, don't you think I would want that wire to be green too?
No.
Yes, I want it green.
You do?
Yeah, they all
No.
the same point.
Okay.
Yeah, they all the same point. Coming off the right-hand side of the light, it's a dot there. That means 2 wires are joined together. So we're gonna
Right.
take that wire and go to pin 5. If 5 is gonna be green, then we might as well go ahead and make this color green,
Okay.
okay? I want you to keep this in mind.
This is just gonna be number 5 off the secondary?
Yes, yes. Need y'all to keep this in mind. The 5 that's on the secondary side going to green, remember the daisy chain that we did?
Yeah.
On the earth ground, and we did a daisy chain all the way through? We could tap off that closest green there and plug it in there. Okay? Now watch this. You're gonna like this even better. Instead of bringing the green light, a green wire from this light all the way to 5, you could take that wire and go to the closest green too as well, because they all the same point.
Oh, okay.
Yeah, I got a diagram of that to show y'all later. So let's move on. Okay, so this is the lab. I'm not going to go over this for y'all because this is part of y'all lab. Y'all got to do some measurements in, okay?
Mm-hmm.
So y'all got to find the measurements. Y'all got to write it down. Testing the control transformer, that's the same thing. It gives you step by step. You read your step by step, right? And you follow the instruction. Read your step by step before you go into the lab Monday so you can get an idea, okay, that's what they want me to do. Some of y'all should be able to do this on your simulator, okay? So I'm not going to cover this. Once again, I'm not going to cover none of this because this is a part of y'all lab. Y'all should be able to go in there, read the follow instructions, and fill in the chart. Okay, and this is skill 5. We're not doing this.
We're gonna do this on Amateur?
Yeah, you can do it on Amateur. You can
Or
do
we're gonna do it in next week's class?
Yeah, before you come into class next week. That way you'll be able to get in and say, oh man, this is snap of a finger. I did this already. But then you're going to demonstrate it because I got it on the rubrics and I got to mark
Okay,
it off.
I got you.
Yeah.
Yeah.
We're not doing this. Because me and Peter in the same agreement. We're not trying to turn y'all to engineers. We're trying to turn y'all into technicians. So we're not going to size the control transformer. We're not going to do all that. There's a lot of calculation in here. So we're going to bypass that. So we finished with this. Okay, so we got one more thing to cover. Oh, we supposed to hold on. Oh, hold on. I skipped something. I gotta go back. We gotta go back and do this. Every time I get out of this, I need to stay into it. Okay, I need to go back to module 3 and go over a couple of these guys. Calculation. We're gonna do a couple of them. We're not gonna do them all, okay?
There he is.
Jeez. Yeah, he made it.
Who that's about it?
Yep, he made it.
Thanks about it. Okay, so guys, I gotta bounce in and out of these screens. So I want to share with y'all my snippet tool screen. Everybody see that?
No, yes.
Yeah.
Nah, well, now I do, yeah.
Hold on, I just lost my snipping tool screen. Hold on. Okay, everybody on the snipping tool, we right there? Everybody see that?
Yes.
Okay, so watch this. So here, because a couple of people got it wrong. A couple of people was having minor problems with these upcoming pages. Okay, so let's look at the first one. First of all, I'm gonna ask a question. Answer to yourself. I'm gonna give you 10 seconds. Is this a step up or step down transformer?
Down.
Yes.
To yourself.
Oh,
Okay,
I was
listen
talking to
here.
myself. I do that all the time.
That's okay.
Me-
It's all
me too.
good. Yo, it's all good. So we know
Number
it's a step down transformer, right? So we try to find
The secondary voltage.
well, I think they just want the turn ratios on this one.
Oh, yeah, that's right.
Yeah. So we got to do the turn ratio. So let me do this. So turn ratio equals I'm gonna put number of turns for the primary. Everybody see what I'm writing?
Yep.
Over the number of turns for the secondary.
Isn't it just going to be 2 to 1?
Mhm.
Yeah, but we got to do it for some people that didn't get it right.
All right.
Okay, yeah, let's hold on. So we got the number of turns on the primary inside, number of turns on the secondary in the bottom, right? So the number of turns on the primary is how much?
100.
100 over what? Number of turns on the secondary?
50.
50. We can cancel out the zeros on the back end. We got 10 over 5. 10 is the primary, 5 is the secondary. 5 go into 5 how many times?
1,
1. 5 go into 10 how many times?
2,
2. 2. 2 to 1.
2 to 1.
Okay. Some people forgot to put 2 to 1 down and they just put like 2 or they put 1. You got to put the 2 to colon 1 or you don't get it right. You get 50% of it. You got to put the whole thing down 2 to 1. Okay. Any questions?
no.
Okay.
on.
I got to go back and share. Let's go back. That's what I don't like because I got to keep going in and out of here. And I want to go back to here.
All I know is these backgrounds are dope.
Huh?
I said, I just like the backgrounds. I feel celestial.
Okay. Okay. So let's go. So we're not going to do them all. We're just going to do a couple of them. So we did a 2 to 1 there. Let's look at, is that a step up or step down?
Step up.
Who else say step up?
I do.
Two, show a hand. So it's a step up because the primary got less turn than the secondary, right?
Yep.
Do we
So
want
it's
to
a
find out
1
what
to
the-
3 ratio.
Yep.
It's 1 to 3.
Nice.
Because
Nice.
because we could take 60 into 180 3 times.
Times, yep.
Cool.
Okay. So let's look at the next one. Let's go here. Hold on. Come on, get out the way. So look at this. On the primary, we got 500 turns. Secondaries, they giving us, what they're doing is they giving us the ratio. So we need to find out what the turns are, don't we?
Right.
So let's do this page. Let me do this. Okay. I'm gonna push sharing this page. Gotta go back and share my snipping tool page.
Wait, I got a question.
Yes.
So if the ratio is 2 to 1, doesn't that mean that there's 2 turns every cycle? So don't we already know how many turns there are?
Sometimes it's not given.
Or
Yeah, sometimes this stuff is not given. You can have voltage, but you can't, you gotta make sure you got the number of turns. Sometimes it's not given. in the application.
So, yeah, I just want to add one thing. So if you have a turns ratio of 2 to 1, that just simply means that the primary has double the turns. The 2 to 1 ratio doesn't tell us exactly how many turns there are in the primary and the secondary. What it means is for every 2 turns on the primary, there's 1 in the secondary. So a 2 to 1 ratio could be 1,000 to 500. It could be 200 to 100. The reason why we use the turns ratio is small numbers because it's easier to do with the math. So, okay, so 2 to 1 doesn't mean necessarily there's 2 turns on the primary. That's not enough to have electricity. It's like back in elementary school with fractions. You might have 10 over 5, and the teacher told you reduce the fractions. So that's what we do with the turns ratio. It's just easier to deal with the math. So.
Got it.
Okay, let's do these. Let's do these, guys. Let's look at this. So we already established the step-down transformer. Let's see by how much. And let's do 2 things at one time. Because the next thing after this is going to tell us, let's find out what the voltage is. So what we're going to do is we're going to find out what the turns are, and then we're going to find out what the voltage are at the same time. So we're going to knock out 2 birds in 1 stone on this. Because that way we don't have to go to the next, I don't have to go in and out, okay? So let's look at this. So they give us the number of turns, right? So the number of turns, and we call it the step-down transformer, right? It's 10 to 1. Seeing that as a step-down transformer, we don't multiply like Peter said before. We do what?
Divide.
Divide.
Divide. So let's look at the first one. The secondary, we got a 10 to 1.
To 50?
Hold on,
Yup,
we got
50.
10 Yeah, we got
Yep.
10 to 1.
Yep.
Okay. We got 500 on the primary, right? And what we do, we put 10 over that. And if we divide it, we get what?
50.
50. Okay? So that'll be 50 turns. So let's put 50 turns here. I just put T up here for turns. And over here, I'm gonna put voltage. Okay? Let's figure out what the voltage is while we still here, right? So it's a step-down transformer, right? We got 240 volts on the primary, right? If it's a step-down transformer, we still do the same thing. We divide, right?
Yeah.
What did we divide?
the number of turns to the ratio?
240 divided by what?
The number of turns.
Why you say 240? Why you say 240?
Because
That's the voltage on the
240
side.
volts.
The alternating current.
That's what's on the primary. Look at the primary. It got 240 volts.
Okay.
Yeah. So once again, we got the turn ratio. We got the turn ratio, and we know the voltage. Yeah, dude, I did. I put 10 down.
Wow.
240 right here, divided by 10.
Okay, so 24
Guess what?
volts.
So we're always
24.
using the same number when we're trying to find the voltage and the turn ratio, we're still dividing and multiplying by the same number, same denominator.
If we got the turn ratio and we know the voltage, we are divided. Because we stepping down.
Yeah, so yeah, the turns ratio is 10. So you take the primary voltage and divide by 10, and that gives you 24 volts on that secondary one. Okay.
Okay, I got you.
Always take the primary and divide by whatever that turn ratio is. And so it's 10 to 1, which is 10, so it's 240 divided by 10.
Okay, so Terrence, why don't you, you try, we're gonna let you try,
The secondary.
yeah, hold on, let's erase this.
All right, so
Okay, where you wanna
the
start
ratio
at?
is 5. The ratio is 5. I'm gonna say that the number of turns is 100.
Okay, what you want me to write down first?
T100.
Huh?
T100 on the left side. You know, you got the T and the V so for turns, put 100.
Where you get 100 from?
Because I divided the amount of turns by the first ratio.
Oh, okay, no, tell us how you did it. Tell us how you did it. Don't just give the answer.
Oh, well, that's how I did it. Like, I took the 5 from the ratio and divided it by the turns, and that's 100.
So you want me to put 500 over
500.
5?
What?
You want me to do this? You want me to put 500?
And then divide it by 5.
5, hold on, yeah, my thing is acting up on me.
I feel you.
500 divided by 5 equals how much?
100.
I know I got y'all looking sideways.
No, you
So
good.
what's that 100 going to equal what?
Turns.
The number of turns for the what?
The secondary.
Secondary. Everybody got that?
Yep.
And as far as for the voltage, you will do the same thing, divide the 5 by the 240, and that'll get you 48.
Yep, very good.
40 divided by 5 equals what?
48
48.
volts.
That's how much we seeing in the secondary. 48. Who's stuck? Anybody who not get that? Brian, try the next one.
For me,
Yeah, let me erase this.
all right, gonna divide 500 by 2 to
No,
get
hold on, let me erase these. Okay, what do you want to do?
I want to take 500 and divide it by 2,
500 divided by 2 sounds good to me.
250 turns, and you take 240 and divide that by 2, and you're gonna get 120.
250 here. Is that the number of turns on the secondary?
Yeah,
On the
250?
third.
yeah, 250.
250?
Yeah,
How much voltage you got?
120.
Because you did what?
I divided 120 by 2. Or,
240.
I'm sorry, 240 by 2. Sorry about that.
By 2, and what you get?
120.
120. Mike. No,
Yeah.
Sabata, you came in late. Take this one, Sabata.
Where'd he go?
Did he leave?
I think he stepped out for a minute.
Okay, he probably looking at Jerry Springer and just got us on hold. Mike, go for it.
All right,
Go for it, Mike.
Jerry.
you're gonna take the 500 turns divided by 100. It's gonna be
Yep.
4,
5,
or yeah,
What
divide.
you want to do, Mike? Talk to me.
divide the 500 by 100 and give you 5.
Okay, 100 equals 5. That's the number of turns?
That's turns.
Okay, that's the voltage.
And you can divide the 240 voltage by the 100.
What you get?
I got
2.4.
4.
2.4.
yeah.
Them the answers. Good job, y'all.
Do you,
Anybody stuck on this?
Nope. Good job on teaching.
Okay,
Yep.
yeah, so we
You
ain't
got-
gotta do no more because we covered this. Because the next thing they was gonna do, try to find out the voltage, which we already covered, okay?
Do you guys know why we have four? What's the purpose of maybe having four secondary voltages like that?
No.
No.
Is it for is it for in the case of a shortage or anything?
Yeah, you're almost there. Remember that different circuits need different voltages to operate. So we
Right.
might have something that needs to work off 24 volts AC. Obviously 120 volts AC is very common. Everything in our house is 120. We might have a small device that only needs 2.4 volts. So in electronics, we often have different secondary voltages to tap off to different circuits that require that specific voltage. Remember, I would not want to buy 4 transformers. Okay, we don't do that because it would be very expensive and transformers are bigger in size. So I could buy one transformer that has multiple secondary windings, and then I could tap those off and connect them and wire them to different circuits that need different voltages. This way, I have a circuit board that's smaller in size, and is cheaper than buying 4 transformers. And transformers are typically much bigger in size than any other electronics out there, and it's also pricey. So this is the reason why to do that. Always remember, guys, we did the math, but you always should understand why or where we apply these things, and so that's the answer. All right.
Yeah. Thank you.
Nice job, by the way, on that. Always remember, ratio goes down. You always divide like you guys did. So good job on that.
Yeah, excellent. You're right, Peter. Thanks again, Peter.
No problem.
Okay, so let's move on. You guys, y'all doing a good job. Good timing. Okay, so let me see. I think I can keep this running. I got one other thing I want to share with y'all. I want to share this. Y'all can see that?
Yeah.
Yes.
Okay. Okay, so come on, get out the way, screen. Great. So once again, we seen this circuit before, didn't we? L1 and L2. How many volts is going across that? How many volts?
We saw it.
208.
208. How about pin 2 and 3 of the transformer, primary side?
208.
208.
If one of the fuses is blown, how much will we see on 2 and 3?
208.
If one of the fuses blow,
104.
don't know. All we know is we ain't getting 208, we got a problem, don't we?
Yeah,
Okay.
that's a fact.
Okay, just remember that. If I don't got 208, if I don't got 208 volt on pin 3, 2 of the transformer, we need to work our way backward. We need to go back. Because it don't necessarily always have to be the fuse. One of the phases could be out. Okay? So if we don't get 208 on pin 2 and 3, we need to work our way back towards the fuse, back to L1 or L2. Okay?
If that fuse is blown, it's more power, right?
No. You
No?
won't even- the transformer, first of all, the transformer wouldn't give us 120 volts out. If the fuse blow, you don't get the power there. You won't get nothing there. You won't get 208. Now, if the fuse
Saying the
blows,
reason why the fuse will blow.
we don't, a lot of reasons. Maybe you might have took a green wire and hooked it to a phase wire.
Yeah, like a short. Yeah, okay.
Yeah, you could have shorted something out, right?
Yeah.
Yeah, usually if a fuse is blown, like Dave says, it was a short, because a short typically indicates
right.
high current. The high current flows through the fuse and melts the link. So, but like
Right.
Dave says, a misconnection can cause higher current that can blow that fuse.
Right, that's what I was saying. It had more power going to it. That's why it blew the fuse.
Initially, right, but then the secondary won't have anything, Mike, because the fuse is blown. So, yeah.
Right.
Yep.
Okay? So watch this. L1 and L2, I'm just going to talk about this. If we go across pin 2 and 3 and we don't get 208, so we know that we have to check the fuse. We need to check the input of the fuse because we know 2 and 3 are connected to the output of the fuse. So we go to the input of the fuse. Watch this. If I go to the input of the 2 fuses on the top portion of the fuse, I don't get 208. Where's the problem at? Where would the problem be?
At the bottom.
No, you're going the wrong way.
Oh.
It's got to be either L1 or L2. The fuse is inside there on the main panel blue. Remember how we supposed to be? Yeah, how we go? First thing we test. Phase to phase. Phase 1 to phase 2. 208. Phase and so forth, right? Somewhere, if these fuses are good and we don't get 208, one of the fuses popped in the panel box. Okay?
Okay.
Let's look at the secondary side of the transformer, okay? The secondary side of the transformer talks about pin 2 and 5. Once again, don't get pin 2 mixed up with the 2 on the primary side. We should be getting 120 volts out if everything is running good. These 2 jumper pins in here, they're called 3 and 4. You don't have to worry about these because they're already jumper internally in the transformer, okay? Any question on this one?
Not yet.
It's backward. See the new screen? We talked about this. We constantly talk about this. Marinate this. Let you go to bed that night and dream about this. L1 and L2, 208, going to the fuse. All the way down to where? The 208 should be seen where? Pin 2 and 3 of the transformer. That 208, if everything is running good, should be down there on the transformer, primary side. Okay? Only thing I'm missing out of this here, I forgot to put the L on the selector switch, guys. Okay. From L1 and L2 to the fuse, you should always read around 208. On the other side of the fuse, you should always measure, that's supposed to be 208, guys, not 280. I made a mistake, typo error. It should be 208, the other side of the fuse. Pin 2 and 3, we talked about this and drill it in your head. We should still be reading 208. This side of the transformer is considered what?
Primary.
Primary side. And the step down transformer, okay? All I'm showing you is the secondary side. I didn't label it. Once again, that's your secondary. This is your control portion, the secondary portion. Secondary of the transformer is your control portion. Okay? All I'm doing is showing you the same thing. Everything in light blue is the primary side. Look at where your fuses are at. The fuses are on the primary side. The secondary side, pin 2 and 5. Look at pin 5. What is pin 5? What color?
Green for ground.
Make sure this is green. Connected to it is ground, okay? This wire must always be ground, not purple, not black, not orange, not iridescent, green.
Got it.
Now, anytime I ask y'all to draw a transformer, this is how simple I want y'all to draw it. Don't make it complicated. Just draw it just like this. Take your time and draw it just like this. Take your time and draw it. You got your L1 and L2 going to a fuse. The fuse is going to pin 2 and 3, and pin 2 and 5 is coming out. I always want to see y'all draw that for a transformer. Primary, go ahead and draw that right quick. We're gonna keep this simple. We don't want a whole big transformer with 4, 5, and 6 and 10 and 11. We just concerned about 2 and 3 in the primary coming from a fuse from the power circuit to the secondary, 2 and 5. Let me know when y'all finished. We good?
Not yet. Another minute. Please.
Got it. We done. 3.
I'm gonna order my sandwich at the store.
Okay. We'll leave it about 3. Zero, I see you got the colors.
What's that?
You got the colors in there, I see. You
I
got
don't know
the
what it's in. Oh. Okay. I'm closing this window. Can I close it? We can't hear you at all.
Everybody finished? Was it finished?
Barely hear you.
Oh, okay. Is everybody finished?
You sound like you getting kidnapped.
I'm not gonna sit down now. I gotta get over it. Can y'all hear me now?
Yes.
Sir,
Okay, everybody
I thought you
finished?
disappeared into a wormhole.
Who wasn't finished with the drawing?
We good.
Okay, can y'all see the new drawing that's up?
Yes, sir.
Everybody,
Can't hear you.
oh, I'm sorry. Can y'all see the modules? Y'all see the modules?
Yeah.
Yes, we
Okay,
do.
great, great. This is the last thing we gotta do, guys. Everybody look at the schematics. Look at the schematics. Look at the schematics, okay? That's on page. We on page S03-5.
I don't think I have it.
You got your book, said you had the book, right? Said you had number 3. Theodore, that's the one I asked you to draw out.
Yeah. Never mind. It's in.
Okay, Theodore, that's the one I asked you to draw out for us, okay? That's what we're gonna be doing. So watch this, guys. Everything that's on that schematic is on this board, listen. What's this? The power, right? What I had to do here was this piece of paper. I had to put a white piece of paper over it because this thing shows up black, but it's a shiny, too shiny. So I had to put a piece of paper over it. This is actually the transformer, right? That's the primary side. That's the secondary side. That's the encore splitting. So I had to do this so it wouldn't be glossy, okay? They're going operating station, right? And there's our indicator station. The only thing we missing out of here is the wire conductor. It said we need a power, we need an input, we need an output. All we got to do is connect the wire. So let's do this. Mike,
Yeah.
you start off. Let's start off with you, Mike.
Okay.
Where you want to start at? Let's work our way from the power and work our way and do the light last. So only give us one thing you want us to connect so far. What you want to connect?
Go L1 to the fuse.
L1 to the fuse. Okay, watch this, guys. Because I don't want to mark on this sheet of paper. Because I only got a limited numbers. So we want to come out of L1 to where? What fuse you want to go to? What side? Anyone?
Left.
Left side.
Well, the fuses are up and down.
Oh,
Yeah, here go the fuses on the top here. This is how you're going to see it out there in Northland. Here's a fuse here.
yeah.
Here's a fuse here. Okay? So you want to come out of L1 and go to a fuse. So we're going to do it like this. And we're going to go to the bottom fuse, okay? So I'm doing this. I'm not going to write on the paper. So is that what you want, Mike?
Yeah.
Okay. You done?
Who, me?
Okay, yeah. Okay, so I'm just asking you, you finished?
Going to the fuse? Yeah.
Yeah, okay.
Want
So
to
you
keep going?
done. Okay, Terrence, go next.
Sorry, I just dropped my notebook.
Oh, we want to make sure that wire is black all the time, guys. Make that wire black.
All right, so I will take L2 to the top fuse.
To the top fuse. Okay, question, anybody? Question, anybody? Did they forget anything? Anybody? Did they forget anything? Both of them.
I mean, to test everything.
Did we
No,
forget
you know what?
anything?
You know what? That's a good one. I forgot. You know what? You know what? I did have a meter here.
There you go.
I did have a meter here. I forgot to do the testing, okay? So we gonna test first, but we already know how to test, right? So I'm gonna put
Yes, we do.
down.
Yes, we do.
Yeah, we forgot to test before we wired, okay? But anyway, I got the meter there. Good catch. There's another thing we forgot to do. If I take my lineman pliers and I bust you upside the head, what you forgot to do?
Mark the line on your
Mark the
diagram.
Mark the line. Mark the line. So both of y'all, we mark that line. You gotta remember to do that, guys, because if I give you something to wire and you run into a problem, and if I walk away from you and your partner says, well, what, you ask him, well, why you walk away from me? He said, well, what you do? He came over and looked at my schematics and the paper, he just walked away. Then he looked at it and said, because you didn't mark the paper up.
Yo, so remind me, what's the significance of marking a line?
It is
So
so
you know
easy.
you finished that wire.
You know you made the connection to that wire. Remember how I kept taking, yeah, yeah, okay, you get it?
Yeah, I get that.
Connection to that wire. It's real.
It's like a check off, pretty much. Yeah, okay.
Yeah, okay. So let's
When there's
go.
20 of them, you need to see it.
Let's go with, we got them two in place. Let's see. Tabata, go next.
Well, I'm not for sure. I'm just writing everything down how we going. I'm not for sure.
We trying to wire this. We trying to wire off the paper. You don't have your book in front of you?
Exactly. I don't have no book. I had to return to Norfolk.
No, the lab sheet that I gave out to y'all.
The lab. Hold on. You said book. I thought you was talking about a book.
No, the lab sheet. Transform, module 3, go to S03-5. Between robots and this course here, guys.
Okay.
Peter gonna give y'all a break when y'all get to PLCs. But when y'all get to this motor control stuff, man, you get this stuff down packed, you'll be okay.
Do you connect it to 4 and 6?
4 and 6. Where you at on 4 and 6? No, you way off track. No. That's what we talked about before. If you look at the drawing, if you did the drawing like everybody else did, they do a transformer.
Yeah.
The minimum. All you gotta do is 2 and 3. 2 and 3. We don't care about 4 and 6.
Okay.
We don't care about that. So far, we satisfy this going into the fuse. Now we gotta come out the fuse. Look at your paper and see what's coming out of the fuse and where it's going.
It's not going to 2 and 3?
We already did that. We already made these here. That's what we did here and here.
Okay.
No.
He's right.
You're right. Okay, you're right. I'm sorry. So we coming out of the fuse. Pick a fuse. Which one you want to do, top or bottom?
You want to do primary, the bottom.
Okay, no. Which fuse you want to work with? This one or this one? It's 2 fuses. Where do you want to come out of the bottom fuse or the top fuse?
The bottom one.
Okay, where you want to go with that? Where you want me to take it to?
Take it to 2.
2. Yeah, and it'll keep us right in there so we don't have to cross over. So I'm going to take that to 2. What you want me to do next?
And then take the top one to 3.
No, you get enough there. What you want me to do next?
You want to take the top?
No, we don't want you to do no more. Theodore, help him out.
Mark the line with a slash.
Oh, all right, all right.
What we do next, Theodore? Take the next one. Okay, you done. Okay, Sebastian, you understand what we doing now?
Yeah, I understand. I understand. I just was going with y'all.
Okay, go ahead, Theodore, go.
Go from the other end of the second fuse at the
Yeah.
top
Yeah,
to number 3,
3.
and then slash through the line, please.
Okay, let's make them, when we go in the lab, let's make all these black, okay?
Yep.
And that's last line. Okay. Brian, it's Brian there, right?
What's that?
It's Brian, take the next one. What we gonna do next?
Let's see here.
Look at this schematic.
Yeah. I honestly don't know. I can't see a freaking.
Huh?
I don't know.
Where you stuck at?
This just doesn't look the same, I guess. Like the other ones made sense, the moves that you guys did on the other ones, but I'm not sure what to do next.
Okay, so who's next in line? Let's go to Terrence, go next. T, what we gonna do next, T?
I am just as lost as anyone else on this part.
Okay. So everybody turn to S02, S03-5.
You gonna come out and transformer?
Okay, so we satisfied everything on the primary side of the transformer, didn't we? Look at the primary side of the transformer. That's the stuff going up.
Yeah.
Right? That's all done. Now we need to look at the secondary side, and we need to start making our connections. So let's start with pin number, I don't know, let me see. Theodore,
Yeah.
what we do next?
Go from number 2
Right, I like that. I like that.
to number 5.
No, 2 to 5?
Well, no, to the ground.
No, 2 and 5. No, not 2 to 5. 2. Let's do this. Watch this, guys. Let's do 2. Now.
Oh wait,
2 to what?
2 to 3.
No. Watch this. I'm coming out of 2 on the secondary side, right? I'm gonna jump over these wires. I'm going up to my selector switch, to the input of the selector switch to the left-hand side.
Okay.
Yeah, look at your schematic.
Oh yeah. All right, that makes sense.
Yeah. I didn't want to mark up the paper. That's where I'm going. Okay.
Yep.
Okay. Don't put green there. Any other color but green. So I use red.
Okay.
Okay. Mike, what you gonna do next?
We're gonna go from 5.
So let's deal with that one last.
Okay. All right. Well, we're gonna come out of
Let's work a series of this.
All right. Then we're gonna go out of the switch to the lamp.
The lamp. Which one?
Well, we're gonna come out of the top. We're
So
gonna
I'm
go.
coming out of here. I'm going down to which lamp? Red, green, yellow. Y stand for yellow.
All right.
Yeah, Y stands for yellow. Okay. Oh, we forgot this. Forgot this.
Mark the wires. Yeah.
Yeah. So that's what we just did there, okay?
Right.
Okay. Who want to take the last one? The last one is not difficult, but it's interesting. Who want to give it a stab?
I mean, the last one has to be going to the ground, right, with 5.
Okay, so that's what you want? You want me to come, where you want me to come from? Here? Here? Talk to me.
I think we should come from the other side of the yellow lamp.
Here?
Yeah.
Where you want me to go to?
To 5, right?
Okay, so I'm gonna come down, and I'm gonna come out, and I'm gonna go over here, and I'm gonna cross over, and I'm gonna go to 5. Y'all like that?
Yep.
Sure.
Okay, watch this. You can do that. You can do that. But watch this.
You're gonna daisy chain it somehow?
Well, no, you on the right track. Who said that?
Teddy.
You on the right track. Watch this. Let's eliminate this. Watch this. You see this 5 here? It's going to
Yes, sir.
connect to that green. A small wire, isn't it?
Oh, okay.
You
Yep.
see this here? You can take a small wire from here and connect it to this ground. Because they daisy chain.
Gotcha.
You don't have to run that all the way back over here. You just tap it here and just there. Because all the greens are daisy chain.
Okay.
Okay.
Okay, I didn't want to draw on that, but that's what you do. You could have did what you did.
But it would have been easier to do what you just said.
Yeah, it's much more easier. So that's the schematic. That's what y'all gonna be doing in lab that day. So if y'all can wire on a sheet of paper, you ain't got no problem going out there and do the wiring on the Amatron.
Right.
Any questions?
No, I'm all good.
Nope.
Okay, let me stop.